Okay, today is Monday, October 17th, 2016, and as you can see by or from the topology here, we're going to be reviewing EIGRP named, or as it's also called, EIGRP address family mode. This is the same topology that was used in the earlier EIGRP for IPv6. However, I've gone back, and as you can see highlighted in blue, I've added IPv4, not there, excuse that one. I've added IPv4 address for the segments between router 1 and router 2. That's 192.168.2.0/30. And on the segment between router 2 and router 3, that's 192.168.4.0/30. Added a 192.168.1 address for the loopback on router 1, another IP4 address for the loopback on router 2 and for router 3, and for the segment between router 3 and router 4. Some of the transition distinctions between EIGRP classic mode, which is activated with the global configuration command router EIGRP and the autonomous system number, is not how we activate EIGRP in named mode. And some of this is, we're just going to jump right in. But I'll say, well, before I jump in, two things. Big contrast with EIGRP named mode is that there is a single process for no matter how many IPv4 or IPv6 address families are configured, there's still one single process. As compared to if I were configuring IPv4 and IPv6 on one router, very simple, that would be two separate processes, two separate locations in the running config to review the configuration, as well as one looking at that in IPv6, there would be the configuration information for starting the router process under the global configuration mode, and then there would be configuration detail under the interface in IPv6. So, and one other piece also, that EIGRP named mode supports VRF, which for VRF for IPv6, which there is no support for VRF in EIGRP classic mode for IPv6. So with that, we're just going to go ahead and jump in. I'm going to scroll. Actually, I'll make the topology smaller and bring in my routers here. Good. Okay, so on router 1, let's see what we have here. Show IP protocols. Nothing. Show IPv6 protocols. Okay. Router 2, show IP protocols. Show IP. Okay, I think we're good. Show IP protocols. Just want to check and make sure and see what was actually on here. So what we're going to do is going to configure a dual stack of IPv4 and IPv6 running between the routers 1, 2, and 3. And what we'll see is what actually triggers the neighbor relationship to come up. And what actually starts the process, the EIGRP process. So we're going to go ahead and jump in real quick here. So first thing we're going to do is go into global configuration mode and say router EIGRP, and look at the question, and there's that word EIGRP virtual instance name, and that's where we're going to say dual stack. Now if I do show IP protocols, Notice, does not say EIGRP is running, that there is an EIGRP with an autonomous system number, because we haven't defined an autonomous system, with the K values and router ID. When router EIGRP dual stack defining or allocating the instance name does not start the process. So what we're going to do now is my notes. I'm actually working from notes because I want to make absolutely sure that I flow through this fairly quickly, because there's not a lot to the actual configuration of EIGRP named mode. There's more of what's going on behind the scenes, and we'll be looking at that in the next session. So what we're going to do now, we define the instance, and we'll say under the address family, IPv4, and look at the options there, and we can say autonomous system, autonomous system, where we'll actually define the autonomous system number, a multicast family, a unicast family, or VRF. Now if I had said IPv6, fewer options, one less option, there's no multicast. Okay, there's an autonomous system, unicast, and VRF. So we're going to go back to 4 and say autonomous system number 4, and we'll give it the number for IPv4. And now if I go back and say do show IP protocols, with that the EIGRP AS is defined. So we see here that the protocol routing protocol is EIGRP4, where 4 is the AS, the autonomous system number. See the name of the virtual instance. See our K values, the metric version 64-bit, and here we see that we're picking up the router ID of 192.168.1.1, which is the highest interface that's configured. So we need to change that real quick, because I want the router ID to actually be 1.1.1.1. So we'll say, look at the command options, and for EIGRP address family specific options, it's EIGRP, and it's router ID, and I want the router ID of 1.1.1.1. And if we look at additional, now next is to define the network. There's a network statement here, a network command. This will not be present if we were defining an address family for IPv6. So I've caught myself in reviews before where I'm attempting to wanting to enter a network and the network command is not there, and what's happened is I've been thinking IPv6 and I've gone into an address family for IPv6 and there's no network statement, no network command. So tuck that away in case if you ever find yourself thinking you should be able to see a network command and you don't, you're probably in an address family for IPv6. So I've done the address family, I've done and now we're going to say network on router. These are for the interfaces on router 1, 192.168.1.0, and network for the segment between router 1 and router 2, 192.168.2.0, and the wildcard mask for a /30, 0.0.0.3. And we'll say exit. Well, actually, let me back up. What I want to do is I want to exit that's all I need to take care of in the address family. And so we'll say exit address family. Okay. And now we're going to configure the IPv6 address family. Address family, IPv6, AS, autonomous system, and we'll give it the autonomous system number of 6 for IPv6. Again, want to assign the router ID of 1.1.1, so EIGRP router ID 1.1.1.1, and address network. Remember that there is no network statement when configuring IPv6. Okay, and let's see, I think that's all I need to do for router 1. So let's take a look. So go back in and show run section EIGRP. And so it's much cleaner, concise structure for the configuration details for the EIGRP named instance. Here we see our name for the instance. There's the address family IPv4 configuration details, and under the IP address address family for IPv6 configuration details. Okay, so now jump over to router 2, and I'm going to repeat that same process, and I'm going to do that fairly quickly. Router for EIGRP dual stack, address family IPv4, autonomous system 4, EIGRP router ID 2.2.2.2, and network 192.168.3.0, which is for the LAN interface on router 2 on loopback 2 3.0, and then for the network segment between router 1 and router 2 192.168.2.0, and wildcard for /30 0.0.0.3. And when I enter this, we should see the adjacency between router 1 and router 2 come up, and it should come up fairly quickly. Good, perfect, there we go. So we've got the neighbor relationship there between router 1 and router 2. And if I do show IP EIGRP neighbor, there we see that we've got the neighbor relationship with 192.168 address 2.1 for router 1. The interface that neighbor and adjacency formed on, hold time 13 seconds, uptime is 16, smooth round trip time 39 microseconds, round trip time 234 microseconds, nothing queuing, and the sequence number 3. So we've got the IPv4 EIGRP adjacency, and now we're going to bring up the IPv6 address family. Exit address family IPv6 autonomous system 6 for IPv6. Notice I didn't put in the router ID, and the neighbor relationship has come up already. So if we do a show IPv6 EIGRP neighbor, we see that the link local address for that neighbor is FE80::1. Very important. Again, we see that it's the link local address that's being used in forming the neighbor relationship, not the global address. Okay, so I still want to go ahead very quickly and say EIGRP router ID 2.2.2.2. And I think should get a change reset because of that router ID. Maybe I'm wrong. I thought for sure it would get a change. Okay, there it is. There's the route change, router configuration or route configuration change, and that was because of that router ID being changed. So a simple change is that router ID breaks that neighbor adjacency, and if there's a high volume of traffic, you just had an outage there. Very quick, but still an outage. So to be done during change management session times and maintenance, not during at 2:30, 3:30 p.m. in the afternoon or at 8:45 in the on a Monday morning. Okay, so we have the neighbor relationship there between router 1 and router 2 for both IPv4 and IPv6. I'm going to end and go back and show IPv6 neighbor, EIGRP neighbor. Okay, and we're going to same content, very similar to the content we saw back here of show IPv6 EIGRP neighbor and show IP EIGRP neighbor. Okay, so we're looking at both pieces here for IPv6 and IPv4. Okay, so we have that neighbor relationship up. And now we need to do the same thing on router 3. So we go into global configuration mode, router EIGRP. I'm going to switch it around and call it stack dual, just to prove that the name does not have to be the same. And address family IPv4, autonomous system 4, and EIGRP router ID 3.3.3.3, and should see the network 192.168.5.0, network, slow down, 192.168.4.0, 0.0.0.3. Did I put that network in? Did I put that 4 network in? Do show IP, show run, section EIGRP. You can probably hear my dog snowing in the background. Let's see, there's the 3. No, I did not put the 4, so I need to go back in. Conf T router EIGRP dual stack address family IPv4 AS4 network 192.168.4.0 0.0.0.3. There we go. I forgot to put in that segment in the network statement for on the IPv4 address family. Did I not? I didn't do it for IPv6 either, so while I'm here I may as well do that. So we're going to exit the address family and go address family IPv6 a autonomous system 6 net. No, I caught myself. There is no network statement, so I can, if I look at there is no network statement. Max preference, metric, and neighbor. So I'm good. The IPv4 information was what was necessary. I had to add the network statement for the segment between router 2 and router 3. So we now have that neighbor relationship up. And we can do exit interface and say address family IPv6, autonomous system 6, EIGRP router ID 3.3.3.3. See, the neighbor relationship already came up. So you know, that's interesting. I'm curious about something. No, that's good. That's okay. So we're going to get the route change, which is going to bounce the neighbor relationship between router 3 and router 2 by changing that router ID. There it goes, route configuration change, and the adjacency should come right back up. But this is an outage, so very important to know that simply changing that router ID does cause an outage. So go exit here and say show IP EIGRP neighbor. So router 3 has the neighbor up on router 2, and show IPv6 EIGRP neighbor. And there's the neighbor relationship form with the link local address of FE80::2, which is router 2. And so we have the adjacency, the neighbor relationships between routers 1, 2, and 3 for both IPv4 and IPv6 configured. As you'll remember, if I say show IPv6 EIGRP, show IPv6 EIGRP. No, what do I want to do? Show IPv6 protocol. I want to show you that I actually gave this what am I looking for? Show IPv6 EIGRP IPv6. Oh, turn off the caps. Show IPv6 EIGRP. Autonomous system is 6, and neighbors. Yeah, there's it. I wanted to show you that in fact I did use a different name for the instance. Here on router 3 I called it stack dual, where on router 2 and I called it dual stack. So the name does not have to match. However, it does make troubleshooting good logical sense to have all of the instances that are supposed to be communicating in an AS with the same name, instead of having multiple names that trying to juggle them around in mind. And so to that, I'm going to I'll change that back to dual stack after the session's ends. So let's see, how far can we ping? If we go back to router 1, can I ping the loopback interface on router 2, that 192.168.3.1? I can. Can I ping the loopback interface on router 3, 192.168.5.1? So we have full connectivity. Now I'll go jump over to router 3 and ping the loopback interface on router 1.1. Okay. Can I ping, and I have a static route, let me show you real quick. I have a static route on router 4. I have a default route on router 4 back to router 3. And did I add a default route? Let's see, show IP route. I have not. So I need to add a static route, because what I'm showing you is if we do a ping of 192.168.77.2, we go nowhere. We do not get there because that network is not known. It's not participating. That segment, that 192.168.77.0, the interface associated with that segment is not a network that's been configured in the EIGRP instance. So what I would need to do, I could actually configure a static route, which I've done already from router 3, from router 4. You know what? I'm gonna change this lab. I'm gonna have it. Yeah, so we're gonna go back to router 3 and say, go into global config mode, IP route, and the destination we want to get to is there a loopback interface here? Show IP in brief. Did I not set everything up completely? No, we're good. We're good. Actually, I think this is rather than let the session go too much longer, I think I'm going to pause here and then come back with session 2, where we're actually going to make some interfaces passive, complete the connectivity so that there is end-to-end connectivity from router 1 all the way to router 4, and from router 4 all the way to router 1, and look at some of the additional behind the scenes of working in the address family interface, again, for doing the passive interface, and looking at what interfaces that are participating in the IPv4 autonomous system. Are all interfaces participating, or only the interfaces configured? Compared to the IPv6 autonomous system, are all interfaces participating, or only configured interfaces? If you remember, there was no network statement, so that's kind of a little hint. So we'll be back for session 2 to which will wrap up the EIGRP named mode. So we have connectivity from router 1 to router 2, router 1 to router 3. However, the test to the IPv4 network on router 4 was not successful there. You see it right there, 0%. Also, just to make sure, ping 2001 db8 feed :77 : 2. Okay, so we have connectivity on the IPv6. Yeah, we got the connectivity on IPv6. I think that's because I've already, take a quick look, show IP route. Oh, show IPv6 route. Yeah, because here I've got a static route in. I would just show run section IP route. I need to slow down and get into IPv6 mode. It's just on another system working in IPv4, and my mind is kind of stuck in IPv4. Yeah, there it is. We have a static route on router 3 to router 4's 2001 : db8 : feed : 77 : 1, and on router 4 haven't added that static route on. Interesting. Show run section IPv6 route. Yeah, okay, so I've got the static routes from router 4 back to first. Oh, this is a holdover. This is from the previous lab where, so I'm gonna leave it. I'm gonna remove this IP route. I don't need this route. Well, I can leave it. It's not hurting anything. This is a route back from router 4 to these loop backs that are on router 3. So it's not hurting anything, and it's not changing any of the results, so I can leave that. But there is a route on router 4 to this network, the db8cap::/48, that whole sub. So that's going to grab everything back from router 1 through router 3's serial 1/1 interface. So that's why we've got IPv6 connectivity. So the only thing I need to do now is on router 3 put in an IPv4 static route. So we'll go into global config mode, IP route 0.0.0.0. When I'm typing all these zeros, sometimes these quads, I always type too many. 192.192.168, and this is going to go to 77.1. Right, and now, okay, now we've got full connectivity at the IPv4 level. We have full connectivity at the IPv6 level, and I think what we're going to do now is move into, take a look on router 3. We're going to be moving through in this lab is looking at the address family interface, how we kind of rein in EIGRP's promiscuous activity. When EIGRP is turned on in IPv4 or IPv6, for IPv4, every network that is configured, every network statement, the interfaces that are associated with that network are participating in EIGRP automatically. In IPv6, when EIGRP is turned on, all interfaces all IPv6 interfaces are turned on. And so we have to kind of rein in this power of being able to form these neighbors and adjacencies by making them passive. So what we're going to do first is we're going to go back to router 3. We're going to take a look and make sure, I think I've already done this, but we're going to go into router 3, into global config mode, still there from setting up that static route. I'm going to say router EIGRP. I think this is the one. I think this is the one where I need to actually change. The name of it is IPv6 protocols. I called it stack dual. Okay, so I have to remember that. So we're going to do router EIGRP. Wow. Router EIGRP stack dual. Address family IPv4 unicast 4 autonomous IPv4 unicast autonomous system 4. And let's take a look at there's what our commands are. Topology configuration topology. So far we've used, we'll be using the address family interface in this session, in this particular session. We've already used the EIGRP command. We've used the exit address family. Metric neighbor will be coming up. So again, you know you're in the IPv4 configuration for the address family configuration when you see the network option, the network command here, because there is no network command in IPv6. So what we're going to do is take a look at topology and base. And in the topology base, this is where we actually, if we look at the commands that are here, this is where auto summary is applied, as well as default information for just controlling distribution. Let's see. I think the only ones then are redistribute for IPv4 routes. I think that's all we're gonna take a look. So this is for redistributing. We're going to be taking a look at the redistribution of the static routes, and that's already gonna be pretty straightforward. It's not. And so what we're going to say here is redistribute static. Now there are other options: redistribute metric, redistribute route map. We'll be doing route maps in BGP and maybe a route map in OSPF, but no route maps just at this point on EIGRP. So we redistribute static and exit and address family IPv address family IPv6 unicast autonomous system 6. Emergency services are having a busy morning, so if you hear sirens, I don't think they're coming into my neighborhood, but it's been a busy morning for them. Let's see, and they're at autonomous system 6 and topology base. And redistribute static. Exit address family topology and exit address family. In, and it's to show IP protocols. Let's see, what we're looking for is, so we have the EIGRP. This is, again, we're looking at the show IP protocols for IPv4. And rolling down, okay, and we see our dual instance. Our name, our EIGRP named instance, K values, router ID, topology base, topology, summarization disabled, which is disabled by default in IPv4 after iOS 15X. And let's come back over here to router 1, show IP route EIGRP. Now, notice the difference here. Before, I'm gonna stay where I'm at. Now, because we've redistributed that static route from router 3 into EIGRP, we now have an EIGRP dual, there's the D, and the EX for EIGRP external, and that's that default route on router 3 to router 4 that's now being propagated into our EIGRP. And if we do a show IPv6 route EIGRP, now we have that that external route from on router 3 being propagated into EIGRP. And let's see, let's do on 2, we're going to take a, let's actually show IP protocols. There was something else I wanted to, notice that again the routing information source, that the gateway is 192.168.2.2. That is the serial 1/0 interface on router 2. We've got the internal distance and the external distance of 170, internal distance of 90. That on router 1, the networks that are being routed is the 192.168.1.0 network and the 192.168.2.0/30. Come over to router 2, show IP protocols. Okay, so we're doing, this is for the EIGRP with AS4. Dual stack is the named instance. The address family protocol is for autonomous system 4, AS4. K-value coefficients are still their default values, with K1 having a value of 1 and K3. The K2, 4, 5, and 6 values are still 0. The router ID is 2.2.2.2. Automatic summarization is also disabled, and on router 2 the networks that are being routed for are these 3 networks: the 2.0 network /30, the 3.0 network, and the 4.0/30 network. And on router 2 we have 2 routing information sources: the 192.168.2.1 network, which is to router 1, and the 192.168.4.2, which is router 4. Let's see. Now, even though the EIGRP unifies the configuration for both IPv4 and IPv6, the neighbor table topology tables and EIGRP routing processes are still separate. So while we have the information in the running config, show run section EIGRP, where we have this in this very clear, concise presentation, all the data there's for our dual stack instance name, the IPv4 details follow here, and the IP address family IPv6 here, and the details that follow that configuration. There are still routing tables that are unique. So if I say show IPv6 EIGRP topology, okay, so the IPv6 topology table, there we go. There are all in a passive state, which is a thumbs up. And because of the way this particular network is designed, there's only one path in and one path out on router. I mean, 2 paths. There are 2 networks that are connected. 3 networks in total connected to router 2. However, there's only one path to specific networks. So since there's only one path to those networks, we only have successor routes, no feasible successors. Can I prove that? Absolutely. If I do the show IPv6 EIGRP topology and say all links, actually we do have we have 2 networks. So on router 2 to the CAF:4, there's one successor, and then no, that's not a feasible successor because it is. No, I was wrong. I'm wrong. I was about to say because that value is not less than the reported distance is not less than the feasible distance of the successor, so we're good. And I think we're almost done with this lab. There's a lot that what we'll do now is going to nail down the topology and looking at my notes. Alright, because right now our loopback interfaces are participating in the EIGRP process, and we don't want EIGRP hello messages going out into the LAN and access layer space. And because now, just thought about this morning, with the a portion of the EIGRP standard having been that's available now in, let me see if I can bring that up. RFC, is it 6878? I can't. Let me find it. And EIGRP RFC. So now that there's this RFC 7868 is the document that is allows for a portion of EIGRP to be opened up, and so that other vendors can actually create routing EIGRP routing mechanisms on their routers, whereas in the past this was completely solid. It was a solid barrier wall. Only Cisco was able to create this. Well, now not only can other vendors, but so can anyone that is clever enough to program. So you could have someone very easily sitting inside the LAN environment that has the capacity to form an adjacency with your router, with the promiscuous messages that are flowing back and forth. So what we want to do is, on router 1, we want to make sure that the only interfaces that are talking EIGRP are the interfaces that must talk EIGRP. So we're going to go into router 1's, and we're going to say router EIGRP dual stack address, get rid of that, address family IPv4 unicast autonomous system 4 address family interface, and we're going to go into address family interface. Move that over so a little bit because that's loopback 10. Let's look at the commands here. One, we could actually do authentication here, exiting, changing the hello interval, changing the hello hold time. This next hop self will be touching on this later. This was one that yeah, I won't go deep on that. I'll just stop and say I will be touching the next hop self, but what's most important for this right now is passive interface. And once we do that, this interface will no longer be participating as actively trying to engage with hello messages to form neighbor relationships. So if I do a show IP protocols, now we see that the passive interfaces are loopback 10. Okay, so I need to go now back into global config mode, router EIGRP dual stack, address family IPv6 unicast autonomous system 6, address family interface loopback 10. Look at the address family address family interfaces subcommands, and again we have a passive interface. Is there anything after that? No, it's just ready for the control. Okay, so exit address family interface, exit address family, and in. Now if I do a show IPv6 protocols, we see we have that loopback 10 interface is now passive. Now to prove it, that what happens when an interface is passive is that it's no longer sending hello messages. I'll do it real quick. I'll just go to router EIGRP dual stack address family IPv4 unicast autonomous system 4 address family interface. I'm going to go into serial 1/0, and I'm going to say passive interface. Serial is 1/0 is the interface over to router 2. So when I say passive interface, we see the neighborhood comes down, and it is down because passive interface. And I'm going to start a capture here. Router 1's HDLC. Should take just a moment here. Wow, it's a noisy day in the neighborhood. And okay, so you see hello sources. Those hellos are only, notice what we're seeing. We're seeing IPv6 hellos. Why? Because look at the source. We're not seeing sources from 192.168.2.1. We're seeing source of 2.2. We're seeing the FE80::2 for IPv6. So as soon as I'm going to change this, so I'm going to say EIGRP. Alright, it's okay, just leave that for now. As soon as I say no passive interface, now see how the screen lights up, because all of a sudden there's an update message, and it is coming, the source is 2.2 to 2.1. Got a update from 2.1 to 2.2. Got an acknowledgement, another update from 2.2 to 2.1. So that's all a result of taking that interface out of passive mode so that hello messages are actually being transmitted across that segment. And as soon as we negate the passive interface, the adjacency returns. So we're going to go over to router 2, and okay, so we can move that. We don't need that, so we're going to go to router 2 and global configuration mode, router EIGRP dual stack, address family IPv4 unicast autonomous system 4. Again, we're going to get into this and then to the address family interface for I think it's loopback 2. Just making sure. Do show IP int brief. Yeah, it's loopback 2. So address family loopback 2 passive interface. And then exit address family interface, exit address family IPv6 unicast autonomous system 6 address family interface loopback 2 passive interface. I think, yeah, I just made a mistake, because if I do a show, IPv6 protocol. Oh, it took. Okay. I'm surprised. I thought for sure. Once I actually end it without typing exit, and it may have just been a memory in my mind, but that because I hadn't typed exit, the command wasn't taken. So I'm going to do a show run section EIGRP, and let's look at the running the configuration for IPv6. No, there it is for the address family IPv6, and the interface loopback 2 is now a passive interface, and there was an exit, but there isn't an exit. Yeah, there's the exit. Okay. And there's the exit for the address family. It must have been just something in my mind. And then on router 3, we're going to do the same thing. Remember, router 3 is called stack dual, because I just wanted to make it clear that the virtual instance name for EIGRP can be, they do not have to be the same across systems. However, from a troubleshooting perspective, instead of having to juggle multiple names, it's much easier to have all the ASs that are participating in the same AS with the same name for the EIGRP. So we're going to go into router EIGRP stack dual address family IPv4 unicast autonomous system 4 address family interface. And this is loopback 30 passive interface. Exit address family interface, exit address family. Then go address family IPv6 unicast autonomous system 6 address family interface loopback 30 passive interface. And exit address family interface and exit address family. End to go back. And I think that's, if we just to verify, if we do a show IPv6 protocols, we see that the loopback should be loopback 30. Show IPv6 protocols. Interface is participating. Let me look at some. I may have made a mistake back there. Show IP interface 3. Thought it was loopback 30. It is loopback 30. Show IP protocols. Okay, loopback 30 is the passive interface on in that instance. Okay, and show IPv6 protocols. Loopback 30 is the passive interface. Oh, this is those other interfaces. Okay, just to make this so that it's clear, I'm going to shut those interfaces down real quick. T router interface loopback 1 shut, interface loopback 2 shut, interface loopback 3 shut, Okay. Yeah, we can just ignore these. These are those loopbacks from the previous lab. But what's most important is that for this instance, loopback 30 is simulating the LAN interface, and it is now in a passive state. So I think now if we can, what does that want to go into router 3? I think that's it for this for right now. If there's more, I will bring up another session. So EIGRP is it's not as complicated as it seems to configure. The critical knowledge that's necessary, that next step of knowledge that's necessary beyond initial configuration and configuring it properly for an environment, is understanding the tools available within iOS to troubleshoot a failure or a network that's not performing the way is expected. And that involves going back to look at the show IP protocols, looking at the show IP EIGRP routes for both IPv4 or IPv6, looking at the topology table, looking at the topology all links table, and weaving a web through those to can systematically look and find and research where a problem is. And it all starts coming back to the very beginning of looking at show IP route. You know, if I'm trying to ping a network and I don't have a route to that network, it sounds really simple. Then the packet is not going to get to that destination. There has to always be a route, and that's the bottom line of what EIGRP is doing. And it accomplishes that if there are multiple paths to a network by having not only the successor route but a feasible successor that it can turn over to almost instantaneously without end user or system noticing that that a link has actually failed. Okay, so that's I think that wraps up this lab for today. And next one will be, let me look and see, I'm going to be doing, oh, we're making the transition to OSPF. So and there's a fair amount in OSPF, which I get to dig pretty deep in that review for myself on OSPF. Thanks again, and see you back when we're in OSPF land.